Okay, in this video lectures, I will like to discuss about some additional summarization regarding what we have learned so far in the previous video lectures. Okay, this is due to the there's some part that I missed to discuss, which is about the logistic regression. And for your information, logistic regression is one of the things that might be important for you to know in order for you to later when we learn about the artificial neural network. And okay, let's discuss point to point what we have discussed earlier. Okay, number one, we have discussed about the how we represent the linear regression equation in two different form, which is one is I have give you some expose which we can, instead of writing the long expression of your linear regression, you can also express it in the matrix form or vector form. And then another way you can also express it in terms of a summation symbol over here, because you know, okay, this one is in order for you to reduce the write a long expression in order for you to represent your linear regression, since if you have a high dimensional input or multiple or high dimensional variable input, then you have a lot of a longer expression to write here. So that's why one way you can express that linear model is by using this summation symbol. And the second things that I discussed earlier, that we also discussed about the cost function. Okay, when we talk about the cost function, is one of the things that you learned before is the R square. Okay, the purpose of R square, if you remember, is we want to find the best fit. Okay, this parameter is measured to find the best fit, whether your linear regression model is best fit with your data or not, is depend on the R square. And another parameter which is similar to the behavior is similar with your R square is called a cost function. And then because cost function, and I also highlight that cost function is one of the common most common method in order for you to apply, or in order to compute the optimization, which is also known as a hyperparameter tuning as well as training. Okay, these three terms is a similar things. Okay, it depend on which source you refer. So the cost function, the purpose is similar to with the R square. Okay, if your cost function is higher, means that your linear regression model is very poor. It's not the best fit to, it's not the best way to fit with your data. So in order for you to find the best linear regression model that fit with your data, then you must make sure that your cost function is as small as possible. And then there's a many method to measure the cost function, and I already exposed with two cost function, which is known as a SSE and MSE. Okay, which is known as a sum of square error, and another one is a mean square error. The third one, which is not exposed to you, is called as a cross entropy. Okay, cross entropy, I will not give you in detail. We will not discuss this one in detail. Just give you some introduction that cross entropy is one of the one type of cost function, and this one is a special cost function that is the cost function that is designed specially for classification model. Okay, what is classification model? Is like your logistic regression. Okay, logistic regression is one of the classification model. However, for linear regression is a regression model. So you need to remember that classification model, the output is in categorical, and then for regression model, the output is numerical. Don't get confused, because even the logistic regression, the name or the word logistic regression have the regression, the name have the word regression, but logistic regression is not the regression model, is a classification model. Okay, the one that under the regression model is only the linear regression. Okay, if you talk about the family of regression. Okay, when you talk about the machine learning under the regression. Okay, and then the third one, we talk about the optimization. Here I just proved to you that what you have learned so far, when you want to find the best linear model that fit with your data, you have learned what we call as a least square method. And then the least square method actually utilizing your cost function, okay, just by solving the partial derivative of your cost function with respect with your beta, which is your parameter, and you assign your this partial derivative equal to 0, you solve it, then you can obtain the best, or the best beta that you can achieve in order for you to create your linear regression model that best fit with your data. So of course this one you already familiar. The method is have been discussed during during your secondary school, when you want to learn them, when you want to find the minimum function or a minimum point or the maximum point of a function. So you must compute the partial derivative of that function, and then you must equal with 0. So that is from that idea actually where actually this least square method come from. However, the disadvantage of this behavior when you have the limitation of this approach is that since you have a big data, then I already proved to you that this one have a disadvantage of doing that, because one of the operation that you need to compute in this solving this expression, that you need to apply the inverse matrix, where if you have a large number of data, then your matrix is very big size. So that's why biggest matrix size will limit it, or will increase the high computational time in order for you to produce the inverse matrix of this big matrix. So that's why the alternative to apply this, or to find the best fit linear equation that best fit with your data, then you must go through what we call as a basic optimization, and one optimization approach, or basic optimization searching approach. And one of the basic optimization searching approach that we learn in this course is what we call as a gradient descent. And then in the gradient descent, what we do is that we do some iterative process where we will keep updating our beta. Doesn't matter is it beta 0 or beta 1, it depends on how many dimension of how many input variable you have. Okay, if you have more than 1, then you have beta 0, beta 1, beta 2, and so on. But this one I just give you some example of one variable's input. So you have beta 0 and beta 1, so you will keep update your beta by using this expression. And you can see over here the similarity between this method and this method is that they are utilizing the partial derivative of your cost function. So that's why we expose to you with cost function, because both methods using a cost function, but the difference is just least square method you are solving the derivative of your partial derivative of your cost function, which equal to 0. But this one you are not solving, or you are not assign it equal to 0. You are compute this one. Once you compute this one per parameter, means that one by one. Beta 1 you compute separately with the beta naught. Okay, beta naught is beta naught, beta 1 is beta 1. You keep updating, and then from there you iteratively you are looping. If you are doing a programming, you are looping it, and then you find, and you will keep do some this iteration until you converge. You find the convergent mode there, or you find the best. Or when we talk about the convergent, is the one that the optimum one. Okay, or how to know that you are already in convergent mode is that when you see that the changing of your beta 1, the new beta 1 is not so much different with the old beta 1. Same goes to beta naught. Okay, the new beta naught update is not the difference between the old and the new is not so significant at all. So meaning that is already converged. Okay, that is already converged. So that is where the condition that you need to stop the updating your beta. Okay, and then we also discuss about the 3 different gradient descent, which is batch, stochastic, and mini batch. And this one I think we already discussed so far what is the difference. And then you also need to remember about what is the definition of the epoch as well as iterative. Okay, iterative and epoch is a different things. Okay, the difference is that when you apply these 3, okay, you just try to see back the previous video lecture, what is definition, how to understand the difference between the one approach and one iterative. What are the one approach, what are the one iterative? So it's a difference there. And then the one that we forget to discuss is this one, which is the when we talk about what we call as a we already discussed a linear regression, but we don't discuss detail about the logistic regression. Again, this is your linear regression. Okay, when we express it in this, the normal way we express as a linear regression equation, and then you simplify with this one equation, you have summation. And we talk about, when we talk about the logistic regression, so what we do is we just take this linear equation as one of the function in logistic regression. If you realize that the logistic regression consists of two functions, the first one is a linear, the normal linear equation that come from this linear regression. However, this equation, okay, produce the V. Okay, V is just some intermediate output, where this intermediate output will become the output of the another function, which is the sigmoid function. So in other words, you can see that logistic regression, in order for formulate this logistic regression, you must compute these two functions. One is linear function, another one is a sigmoid function. But for the linear regression, you only have a linear equation over here to compute the output. So if I draw it into a block, you can see over here, this is the linear function where you only have a f1, one function only, where this is one is a linear function over here. So if in order for you to produce the output. However, for logistic regression, it consists of two. Okay, f1 here is a typical linear equation over here, and then it will produce the V. V will become the input for this f2, where f2 here is your sigmoid function. Okay, again, this one is your linear, and this one is your sigmoid. Okay, that's how you compute the logistic regression. And then I think you also question about, okay, how to compute the can logistic regression compute the multi-class output. Of course, it cannot do that because of this sigmoid function, because the limitation of sigmoid function only produce the binary output, or it can produce two classes of output. Okay, so that's why another way you can change this logistic regression is by changing it into this model, where what we call as a softmax regression. Okay, I think they call it as a softmax regression, or some also call this one as a multi-class regression, multi-class logistic regression. Okay, multi-class logistic regression, where actually this is the same linear function. Okay, this one is the same linear function. However, this one they use what we call as a softmax function. Okay, so you can see over here, just by changing the f2, it will change the name of the function. Okay, that is one thing you need to realize. Another thing is that you can see over here, among these three, the one that consists only one function is a linear function, linear regression, because you only have f1, which is your linear function. So of course, you can also make a equivalent block diagram, which is like this one, to present your linear function. So how you do that is actually you can do something like this. Let's say this is your input, and then this is your output. Okay, this is your output, this is your intermediate output. So this is your f1, where this one is the similar linear function. And then how to make your f2 if you want to make this one equivalent to this one. Okay, of course, one way is you can set your f2 over here as what we call as identity function. So what is identity function? So for those who take the image processing might familiar with this function. Okay, what is identity function? It should look like this. Okay, this is your V as the input, this is your Y, so this is your identity function, meaning that y is equal to your v. So in other word, this is identity function. So in other word, if I set my f2 with identity function, meaning my y here is equal to v, meaning that input is equal to the output, meaning that there's no process at all here. So it's similar to this one. But why I still want to draw in this block? So because we want to make sure that everything become general. Doesn't matter is it linear, logistic or softmax regression. You can realize that the f1 should be a linear function, but the one you keep change is f2. If you put the identity function, it become linear regression. If you put a sigmoid, it become logistic regression. And if you put f2 equal to softmax function, it become softmax regression. And later you will see that in artificial neural network, you have a lot of function that can be set as f2 over here, where actually by changing the function of f2, it will become another regression family models, where actually this regression is a part or is some basic things inside your artificial neural network.